Hello viewers, this is Wargoda Ronald taking you through the tutorial for A-level Mathematics paper 2, and this video we're going to talk about questions on work, energy and power. And this topic is on mechanics and beneficial to students in both senior 5 and senior 6. Now these are the very questions I left in the previous video, and I believe by now you have already tried them out and ready to mark yourself and check your progress. So we shall start with question 1, and question 1 came from UNEB 2018 paper 2 question 4, and it says a particle of mass 15 kilograms is pulled up a smooth slope by a light inextensible string parallel to a slope. The slope is 10.5 meters long, inclined at arc sine 4/7 to the horizontal. The acceleration of the particle is 0.98 meters per second squared. Determine Roman 1 the tension in the string, and Roman 2 the work done against gravity when the particle reaches the end of the slope. So here the best way to answer such a question is to first draw a force diagram. So let's first draw a force diagram. For each draw a force diagram, we have to first get this angle or the inclination. So arc sine 4/7 is equal to 34.8499 degrees. So now that I've got the inclination, I can come and draw my sketch. So this is the slope inclination, 34.8499 degrees, and this is the slope inclined plane, and this is the particle. Now they told us that the particle is of mass 15 kilograms, so we are going to first come and show the weight of the particle. So the weight is 15 g newtons, and you have to resolve it into two components. One component parallel to the plane, and it will be 15 g sine 34.8499 degrees, and the component perpendicular to the plane will be 15 g cos 34.8499 degrees. Now remember, note that the resolved components are represented by dotted lines because they are not other forces. It's just a resolved component of the force which is on the diagram. Now next we shall show the normal reaction acting on this particle, and it's represented by R. Then next will be the tension in the string, which is pulling, and this is what they want. So part A, we have to get this value of T. Now we are also given the acceleration being equal to 0.98 meters per second squared, as you can see it here. So we shall come and show the acceleration there. Now we shall start with part A. Part A says that find the tension in the string. So to get the tension, we are going to resolve parallel to the plane, and when we resolve parallel to the plane, we shall get T minus this will be equal to MA. So just the T minus 15 g sine theta is equal to 15 times 0.98, where 0.98 is the acceleration and 15 is the mass. Now we know that sine theta is equal to 4/7, so we shall come and substitute for sine theta and substitute for g. Then we come up with it, and when we make T the subject, we shall come up with T being equal to 98.7 newtons. So basically that's what they wanted in part A. Now we shall go to part B, which says determine the work done against gravity when the particle reaches the end of the slope. So we shall come at part B and say, first of all, vertical height moved will be equal to 10.5 sine theta. So we have to resolve that inclination. This is the hypotenuse, so the vertical height will be 10.5 sine theta. But I know sine theta is equal to 4/7, so I come and say that my height will come up with, when I substitute for sine theta, will come up with my h being equal to 6 meters. So now that I know the vertical height, I can come and get the work done against gravity being equal to mg h, where m is the mass, g is the acceleration due to gravity, and h is the vertical height. So when I substitute, I'll come up with that, and therefore my work done will be equal to 882 joules. So basically that's what they wanted in this question, and now we can see how marks can be awarded. So B1 is for drawing a correct force diagram, and remember, force diagrams are drawn using a ruler. Then M1 is for you to resolve and substitute, and then A1 is for getting the output, which is the tension they want. Then for part B, M1 is for substituting in the formula for work done against gravity, but this height must also be shown. You don't just do it as side work, but it has to be shown on paper. Then A1 is for the final answer, which is the work done against gravity. So basically that's how the 5 marks could come about. Now we shall go to question 2, and question 2 came from UNEB 2017, paper 2, question 8, and it says the engine of a lorry of mass 5,000 kilograms is working at a steady rate of 350 kilowatts against a constant resistance force of 1,000 newtons. The lorry ascends a slope of inclination 30 degrees to the horizontal. If the maximum speed of the lorry is 20 meters per second, find the value of theta. So the first thing to do is to show the force diagram. So this is what we are given, and we know that the attractive force is equal to, remember, power is equal to force times velocity, therefore force will be equal to power over velocity. So the forward force will come up with, this is power is in kilowatts, so you have to change it to watts. That's why you see here 350,000. The velocity is in meters per second, so it is 350,000 over 20 to come up with our attractive force being equal to 17,500 newtons. Then you shall know that at maximum speed acceleration is 0, and therefore we can now come and draw our force diagram. So this is the particle and this is the inclined plane, and we are told that the lorry is of mass 5,000 kilograms. So we shall come and show the weight of the lorry being equal to 5,000 g newtons, but that 5,000 g newtons must be resolved into two components, one part of the plane, and the component part of the plane is 5,000 g sine theta, then the component perpendicular to the plane is 5,000 g cos theta. Now that we know the weight, we shall come and show the normal reaction R in that direction. Then we are also told that the resistance is 1,000 newtons. As you can see here, the resistance force is 1,000 newtons, so you'll come and show it there. We also know that we have also calculated the attractive force, or the pulling force, is 17,500, so we shall come and show the pulling force as 17,500 newtons. Then we also know that the roll is moving up the plane, so we have to represent that by acceleration, but because it's at maximum speed, the acceleration will be 0. That's why you see here A equal to 0. So now that we have shown the force diagram, we shall go ahead to answer the question. They want you to get the value of theta, and for you to get it, you are going to say, resolving part of the plane, what will happen? So when you resolve part of the plane, we shall get this forward force, which is 17,500, minus these resisting forces, which is 1,000, plus the component of the weight part of the plane, which is 5,000 g sine theta. It will be equal to ma. Now m is 5,000 kilograms, that's why you see here 5,000 a. I think you realize that we already know a as 0, so we shall come and substitute for a and for g, so that we remain with only one unknown, which is theta. And when I make theta the subject, I'll come up with theta being equal to 19.68 degrees. So basically that's what they wanted in this question, and now let's see how marks can be awarded. So first mark is for you to calculate the tractive force or the pulling force, that is B1. Then another B1 is for you to draw a correct force diagram, and remember, force diagrams are drawn using a ruler. Then M1 is for you to resolve and substitute. Then another M1 is for you to remember that at maximum speed acceleration is 0. So when you equate it to 0, when you equate the resolved force to 0, that is where the M1 is coming from. Then when you simplify and get the final answer as 19.68 degrees, that's why you get the final mark, which is A1. So basically that's how the 5 marks could come about in this question. So now we shall go to question 3, and question 3 came from UNEB 2016 paper 2 question 4, and it says a body of mass 4 kilograms is moving with an initial velocity of 5 meters per second on a plane. The kinetic energy of the body is reduced by 16 joules in a distance of 40 meters. Find the acceleration of the body. So first of all, you are going to first draw a force diagram. So that is the body resting on a rough. They say that, okay, they didn't talk about the roughness, so what we are going to do, we shall now show the weight. Then also show that the forward force is 0, but the resisting force, there is a resistance, and let that resistance be Fr. Now remember, they have told us that the kinetic energy is reduced by 16 joules in a distance of 40 meters. So that is why we are putting there the resistance, because the kinetic energy can't reduce when there is no resistance. So that is why there is this resistance acting on the body. So now shall come and say, we remember that from work energy theorem, work done against resistance will be equal to change in kinetic energy. So there is work done against the resistance is equal to resistance times the distance moved, which is 40 meters, will be equal to change in kinetic energy, which is 16 joules. And when I make Fr the subject, I come up with my resistance being equal to 0.4 newtons. But remember, in the question they want us to find the acceleration of the body. So now that I've got Fr, I'll come and resolve horizontally and use Newton's second law to come up with the resultant force being equal to 0 minus the resistance, which is Fr, being equal to Ma. Now I know Fr, I also know M as 4 kilograms, so I can come and substitute to get the value to remain with A as an unknown. And when I make A the subject, I come up with A being equal to negative 0.1 meters per second squared. So basically that's what they wanted in this question, and now let's see how marks can be awarded. So M1 is for you to calculate the work done against resistance, and another M1 is for you to equate that work done against resistance to the change in kinetic energy, and B1 is for you to get the resistance acting on the particle. Then for this part, M1 is for you to substitute in Newton's second law of motion, then A1 is for you to get the acceleration which they want. So basically that's how the 5 marks could come about in this question. So now we shall go to question 4. Question 4 came from UNEB 2008 paper 2 question 6, and it says the engine of a train exerts a force of 35,000 newtons on a train of mass 240 tons and draws it up a slope of 1 in 120, know that word, 1 in 120, against resistances totaling to 16 newton per ton, know that word, 16 newton per ton. Find the acceleration of the train. So you have to draw a first diagram, but before you draw the first diagram, we are going to first get the resistance. So resistance, remember they told us that the resistance totals to 60 Newton per ton. So we have to multiply that 60 times the number of tons, and the tons were 240. So when I multiply, I come up with 14,400 newtons as my resistance. Then we're also told that the inclined plane is of a slope of 1 in 120. Now that slope of 1 in 120 means that the inclination is equal to arc sine 1 over 120, and when I get arc sine 1 over 120, I'll come up with my angle of inclination being equal to 0.4775 degrees. Now that you have got the resistance and the inclination, we shall come and show the given information on a diagram. So this is the particle, and this is the inclined plane, and this is the angle of inclination. So what we need to do is to show the forces acting. Now for you to show the forces acting, we have to remember that the mass was 240 tons. So remember, 1 ton is equal to 1,000 kilograms. So I have to first convert to 1,000 in terms of kilograms, then I get the weight by multiplying by acceleration due to gravity. So I'll come and say that the weight is 240,000 g newtons, but I have to resolve it horizontally and parallel to the plane and perpendicular to the plane. So parallel to the plane is 240 g sine 0.4775 degrees. Then the component perpendicular to the plane will be 240,000 g cos 0.4775 degrees. So now that I've got the weight, I'll come and show the normal reaction R in that direction. Then remember, we are told that the pulling force, as you can see here, the pulling force is 35,000 newtons. So I'll come and show it here, 35,000 newtons. Then the resistance, as we calculated here, it was 14,400. So we also come and show it here. Then you also have to show the acceleration to show the direction of motion of that particle. Now that you have shown the first diagram, we shall now go and resolve parallel to the plane. So parallel to the plane, we shall say this minus these two forces will be equal to ma. So I'll come and substitute to come up with that step, and I think realize that G is known as 9.8, therefore it is only A which is unknown, and it is the one which they want according to the question. They want the acceleration of the train. So when I substitute for G and make A the subject, I'll come up with my A being equal to 0.004167 meters per second squared. So basically that's what they wanted in this question, and now let's see how mass can be awarded. So B1 will be for you to calculate the resistance, then another B1 for you to draw the correct force diagram. Remember, force diagrams are drawn using a ruler. Then M1 is for you to resolve, another M1 is for you to equate to MA, which is 240,000 A. Then A1 is for you to simplify until you get the acceleration which they want. So basically that's how the 5 mass could come about in this question. So I believe you have marked yourself and checked your progress. So what I'm going to do, I'm going to leave you with another set of questions, and these questions will be on the topic of linear momentum and impulse. This topic is still under mechanics and beneficial to both students in senior 5 and senior 6. So that brings us to the end of this video. Thank you for watching, and be reminded that the solutions to the assignment left in this video will be available in the next video. So if you have not yet subscribed, please click on the subscribe button below this video such that you can receive updates when the next video the solutions has been uploaded. Otherwise, thank you for watching, and also if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family.